All right, what I'm looking at here is this is a physics is electrical day. That we're going to go through this, and I'm going. This is a sort of a. I've added some slides to this presentation from the last time I did it, but you guys haven't seen this one anyway. The other guys that are coming in haven't seen it. But one of the things you got to realize, there's 5 basic rules here. Amp flow times resistance equals voltage drop. Now, voltage drop is how much you're losing across a load, right? Like for example, there's one of these little sheets I'll give you where you got to wire up a circuit, and there's a resistor that's in there in series with it. And if you put your voltmeter, put it on volts, measure on both sides of the resistor. When current's flowing, you'll see how much voltage is being lost there. If you go to the positive terminal on your battery and the big, positive terminal on your starter, and you spin the starter over, you shouldn't lose more than 1/2 volt between the positive battery terminal and the starter. If you're losing more than that, you need to clean some terminals. Negative side, you go to the starter body and you go to the negative battery post and you spin it over again. You're only allowed to lose 1/10 of a volt on the negative side, 1/2 volt on the positive side. You can actually, let's say you had a headlight that was burning dim on one side of the truck and bright on the other. You go to the positive battery terminal and that wire that's feeding power to the headlight, if you go from there to there and you see a bunch of voltage drop, then you got to go find out if it's in a switch, a wire, the connectors, whatever. You see where I'm going with that? You basically can find out where it's at. But what if you don't read any voltage drop on the positive side, you go to the negative side, you find a bad ground that way. Got it? There's a voltage drop thing. Amp flow times resistance equals voltage drop. Current follows voltage. So basically, whenever voltage comes first, if you're looking at it on a graph, your voltage comes up first, and then the current comes up behind it. Follows about 90 degrees. And I'm not going to go into these things a whole lot. Just kind of remember, a byproduct of current is heat. I went to a class one time in Louisiana down there when I was at Chrysler School, and the instructor was goofy enough to try to convince 12 mechanics that resistance doesn't make heat. Whenever you wire up that little thing with the resistor that I'm talking about, I've actually got the resistor, I got a little thing that says hot. And I've actually told people this is hot, and had people grab it and see, and then when I tell them it's hot and they touch it anyway, whenever current's flowing through resistance, it gets hot. It also destroys connectors if it's current flowing through a connector, like this one right here. See, these little wire connectors right here. If a little oxidation happens in there and it gets to where it starts to develop resistance, then it gets hot and it burns up, and it's finally current quits flowing at all. See that? Or a series circuit is a voltage divider circuit. All right, so if I've got a bunch of bulbs, you remember that worksheet I gave you where you had to draw those bulbs in series, the electrical one? And if you basically measured it, each one of those bulbs would be dropping some voltage. So that's voltage drop across each bulb. So you're dividing that voltage. It's going to share, every time the voltage goes through another load, it's going to drop a little lower, a little lower, a little lower. And that's basically what that's about. Get into that a little bit stronger. Parallel circuit is a current divider circuit. If you've got a parallel circuit is whenever every load has got its own ground, and each one of those is going to be pulling some current, right? And so just these right here are just little quickies. I'm going to move on. What you got to do when you're troubleshooting a circuit, you got to do this. You got to find the circuit protection point. I'm going to go find the fuse. I'm going to go where it's easiest. Remember what I'll tell you, go to the easy place first. Go find the fuse. Make sure you're on the right fuse. Don't assume that if you got a fuse on a lot of these, on some of these Fords and everything, you actually have got a lot of fuses in there, and they got funky little numbers on like F124 and all that. Make darn sure you're on the right fuse, because if you're on the wrong fuse and you think it's good when it's one that you're supposed to be checking is blown or whatever, you'll get in trouble. Check for power in and through that point. So has it got power coming to the fuse? Has it got power going through the fuse? The fuse has got those little naked terminals on there where you can actually see if there's power on both sides of it. You can also, if you're checking for a parasitic drain killing the battery, you can actually get on either side of the fuse with your meter. If you get your meter set on a really low setting, if you're dropping voltage across that fuse, because you're always going to have some voltage drop where you have a connection, you can actually go to all of your fuses and check voltage drop across them. The one that's dropping some voltage is going to be the one that's feeding your parasitic drain. That's another story. Locate a wiring schematic. Know how to read a wiring schematic. We went over something last week. If you don't know how to read a wiring schematic, you're going to be crippled. For 6 years after I started working on cars, I never saw a wiring schematic. And I worked with my dad nowhere, and he opened a shop in 1963. No, it was before that. It was like 61. He opened a shop. He had never worked on cars. He rebuilt tractor engines with his dad and stuff. But whenever he got out of the Army, and he married my mom over here, and they came over here, and he says, nobody wants to work on these foreign cars that these soldiers are driving around here, so he threw up a sign that said foreign car garage, started taking in work. A lot of business licenses. He just bought him some tools, started fixing cars, and for 30 years he had a shop. But he didn't have wiring schematics, he didn't have shop manuals back then. He basically just figured it out as he went. You could do that in 1961. You can't do that now. It's a totally different world. All right, locate relays, connectors, and other components. You got to be able to find the various components along the way. It's kind of like a road map, You got to go along here and say, look, this goes here, it goes to that relay, goes through this connector, goes down that wire, comes over here, comes out that switch, and you got to be able to track those things down and be able to. Now, let's say that you've determined, I've got, like on the headlight thing, I got from between the positive battery terminal and this one over here, I've basically got a bunch of voltage I'm losing, right? And so I got to find out where that voltage is being lost at. So what I'm going to do is I'm going to track it from, go follow that circuit, and I go say, where's the last place it goes before it gets there? It goes to this relay. Where's the last place it goes before it gets there? It comes from that switch or that connector. Of course, I check the easy ones first and see if I can hold it there. You got to be able to track those down. Determine the integrity of the circuit. You got to find out, is the current able to flow through here unhindered? Remember, half a volt positive, tenth of a volt negative, right? Can you remember that? Half a volt is all you're allowed on the positive, tenth of a volt on the negative. All you're allowed out. Determine the integrity of the component. Is this motor pulling too many amps? Is it blowing my fuse because the windings in there are melted? Is my alternator bad? The alternator winding and stinking and all that. Motors do that too. And that'll be something else you need to do. All right, so circuit protection, power source. B plus. Is B plus hot all the time or just when the circuit's powered? Some people will get confused whenever they shake on the test light and they'll say, there's not any power going to this fuse. Well, no, but you may have to turn a switch on or activate the circuit before it gets hot. So if there's not power going to it, don't think the fuse is bad. If there's none coming in, then it's going to go out, right? I trained a boy one time. He'd go out there to work on a forklift, and whenever this forklift won't start, and he would turn the key, and so he would check the power on the back of the switch, and every terminal on the back of the switch he'd check for power, and there was no power, and he'd replace the switch. What's wrong with that picture? No power coming in, no power is going to go out, right? And so I'd draw on the board. I'd draw a simple 2-terminal switch. I said, Tom, look, here's a bar. Here's this switch is open. In order for power to go through it, power's got to come to it, right? You understand that? Oh yeah, okay. So it's now you got to find out why doesn't have any power going to it. I went over and helped him figure it out and all that. And I don't remember what the problem was, but it wasn't the switch. And so about a week later, he comes back in there. I couldn't find any power on the back of this switch, and I replaced the switch, and it still won't start. It's the same thing over again. We just went over this the other day, right? Understand the fact that if there's no power in, no power will be going out. Check for power to and through the circuit protector. That's going to be your fuse. Is the fuse or fusible link open? Now these right here, these little fuses right here, they make these fuses fit in there real tight. Okay, so you got to be careful that you don't smash these trying to pull them out with the right wires. So be really careful with them. You can actually pop that little cover off the top and you look down there. Usually you look through that window. If it's all scorched and burned so you can't see through it, then that's suspect already. But a lot of times whenever people are doing this voltage drop test for parasitic drain, they'll pop that top off of there and so they can actually touch both sides of that fuse down in there. But you can look through those, look at those fuses and see. If there's a fusible link is actually a little bit smaller than the wire it's protecting. It's got high-ply insulation on it. It's a special kind of wire, so that if there's a voltage surge, it'll burn that wire in two inside the insulation, right? If it's open, did it just get tired, or are there too many amps flowing? Sometimes the fuse just gets tired and blows. One of the most aggravating things that we used to deal with at the Ford dealership was whenever there would be a car, or any place I've ever worked, there's a car that about every 4 or 5 days it'll blow the stoplight fuse. You can drive that thing, you're blue in the face. You can look at all the wires, all the wires you want to. So what we used to do, as a last resort, and we would take, this is a 10 amp circuit breaker, right? I mean, it's sort of a, seems like a chop up fix, but if somebody's got, this thing will reset itself. It'll actually go ding, ding. So it's like a fuse that replaces itself, right? And if it's just a momentary short, it's only there once every 4 or 5 days and you can't get it to act up, that's an option. You can actually mount that over there and run that circuit through there. Bypass the fuse, run the circuit there. We've actually had to do that. Ford had us doing that on some of these vehicles that were had the current, too much current was being pulled by the fan. It was melting the fuse box. And so, or melt the fuse. And so what we would do, they'd had us cut that and put a circuit breaker in there. And so that's why we had those in stock anyway. There was actually a fix for that. There's a lot of people, having to actually go track down. What you can do, if the wire only goes from one place to another place, you can actually just replace that whole wire. That's really the best way to do it. But on the stoplights, a lot of times it goes several places. You know what I mean? So if you can't just cut the wire out, if you don't cut the wire out, you're going to still have a short. If you cut the wire out and it branches off and goes other places, there are going to be some things that don't work. See what I mean? That's the thing on that. And, what y'all doing out there and not in here? All right. So, all right. All right. Know how to find the right schematic. Understand the symbol. Be able to trace the circuit path. Note the role of any related modules. Now, what you got right here, like see this right here is your fuse block. There's BCM fuse 19. That's feeding the body control module, right? And you say, if I'm concerned about this one here, you know what RAP stands for on the General Motors? The RAP module, or the RAP, is retained accessory power. Can you remember that? If I hit you with it on a pop test, are you going to remember it? Retained accessory power. Retained accessory power. Now a Ford, it's remote anti-theft personality. They both have RAP modules, but one's a remote anti-theft personality, one's a retained accessory power. Know what those acronyms mean, because you may get totally confused if you're thinking the wrong one. All right. See how you can do that? Know the current, be able to trace the current path. So this is actually going to energize that relay, and this is basically going to pull some power from B+, and it's going to send it over here through run 1 and run 2. There's two fuses right there. And this one right here is your retaining accessory power, which goes to sunroof, RAP 2 and RAP 1, which is what retaining accessory power is. How whenever you shut off the car and the radio's still playing and all that stuff, and the windows still work until you open the door? That's what retaining accessory power is. You got that? I mean, everybody familiar with that now? You know what I mean? Like if you've got all those things that aren't working, is it a possibility you could have a bad RAP relay? Could be. All right. So, find out where the connectors, modules, relays, and components are. This is how you do that. You're going to go over here and you're going to see that. This right here is the connector pin out. You can actually remember how we told you you're following that circuit, right through the pins and all that. And they've got most shop manuals. They've got a vaguely. They don't all look exactly like this, but they're going to give you an idea of where it is. See, this right here is the back door. That's the package tray area, and this right here is going to tell you, where the particular thing is. And when you find that particular connector, radio C2 or whatever, then you'll be able to figure out. This is not telling you what those numbers up there are. This is telling you what those pins here are. So basically, I've got that one wrong. But finding the connector and then going to the connector and finding the wire that's in question is what you're after on that. Pay attention to the circuit, wire color, and the pertinent connector cavities. Remember, we went through that last week. All right, so you got to locate components and connectors and see how those cavities look. And if you actually think you're on the right connector, and this particular cavity 3 here or whatever doesn't have a pink wire in it, and the schematic says it's got a pink wire there, then you may be off base. You may be on the wrong connector. Or relays. If you got a relay here, I got all these relays hanging there. How do I know which one is which? Okay, so I'm going to look and I'm going to find the one that's got the same 4 color wires going into it. That this, if it's got a blue, a red, a green, white, and all that, you're going to say this particular one has got the right wire colors, and this is probably going to be what's feeding the thing. See if you got power going to it, power feeding the coil, the relay, and all that. Long and short of it is you got to be able to track these connectors down. All right. So determine circuit integrity and circuit component integrity. All right. If you take your situation here, like here's your PCM, heated oxygen sensor. All right. What I like to do, let's say I've got a heated oxygen sensor, is throw me a code, PO135, I guess. And PO135 typically means that the engine controller is looking for that heater, and when the power's coming through that heater, that powertrain control module is going to energize that heater when it wants that oxygen sensor to get hot. Of course, it does that as soon as you start it up. All right, so let's say that you're getting a code for that heater right there. One of the things that I like to do is take that oxygen sensor and unplug it if I can get to it, and I like to measure that with an ohm meter. You get your meter, put it on 200 ohm scale, and you ought to see about 4 to 6 ohms right there. All right, you've actually checked the integrity of the component there, which I'll get to in just a minute. That's what that is. But let's say that you've got 4 to 6 ohms of it, you're still getting that code. What do you do next? All right, I'm going to say, well, what other stuff is being fed by that same fuse? Well, here's a splice, and that's going over here to this other heater. I'm not getting a code for that heater. I'm only getting a code for that heater. What are the possibilities? I could have a cut wire here. I could have a bad splice there. So do I have power right here? I need to know that. And do I have a ground right here coming from the engine controller? What I like to do is take an old oxygen sensor. When I replace an oxygen sensor, I like to cut the connector off of it, and I like to wire a little wire in there. The 2 wires on an oxygen sensor connector that go to the heater are always the same color, typically. I mean, on an old style oxygen sensor, there'll be 2 brown wires, 2 black wires, or 2 white wires. And the other 2 wires will typically be gray and black, something like that. So what you're going to do is you cut that connector off, and the 2 wires that are the same color, you wire a light bulb into those 2 wires. Oxygen sensor is gone. You got a connector in your hand, right? You're going to plug this into the wire harness, crank it up, see if that light comes on. What do you know now? Somebody tell me what you know now.
They got power.
You got power. Well, typically, when you got a situation where you're getting that code, but this is good, if these connectors aren't messed, if the pins aren't bent or messed up or chalky or whatever, then you're basically going to find out that you've got a problem somewhere on this circuit here, or somewhere on this circuit, or even a bad engine controller. Something inside the engine controller that's trying to operate has no driver in there. So being able to track that down, and instead of saying, well, I'm getting a PL135, I think I'll throw a PCM and an oxygen sensor and a fuse panel at it. Really? What you're supposed to do is track down what the sound bill is going on. See, this is good for you too, right? All right. I take my little test light here, what I can do, I can go right there and see if I got power. All right. That's when I put the light in there. See, I took the oxygen sensor out of the loop, put that light in there, and there's the light. See, that's giving us all this information real quick. I like a go, no-go test that you can test and it'll tell you yes or no. Now there are some tests you can do, like an alternator stator test using diode check. If it fails the test, you're done. If it passes the test, there could still be other things wrong. So some tests aren't no-go, no-go. Some of them are. On the ones where you hook a fan up and turn it through to see if the light goes off, like I've showed on some of these other things, that's a go, no-go test. If it passes that test, then there's nothing wrong with that fan, if it's not blowing a fuse or something. All right, think before you wrench. Wait a minute. All right, fix anything, you gotta understand it. The 04 Seaver is running hot at stoplights and drive-through lanes. What might cause that? What's it usually? But a fan issue. If ever you're sitting still and it starts to overheat, you got a fan problem, right? All right, so now we got to find out what more is going on. That's the shadow of the person that took the picture. All right, so points to a fan issue. Today's vehicle is a critical part of the cooling system. All right, so you got low-speed fan relay, you got high-speed fan relay, and you basically got ground down here. The radiator fan's got both of these motors are all built together, so you got 2 motors. It's kind of like what we're going over here, right? All right, low fan relay control, high fan relay control. Now, rather than having the 3 relays, this one here just got 2 relays. And it basically has the motor set up. Now you might notice you're looking at whenever you look at a motor that's drawn like that, and I usually have a piece laying up there to show you. Oh, right here. You see this electric motor right here? You see the little part where the brushes ride? You see that? That's the commutator. That part right there where the brushes ride. Okay? What you're looking at when you look at that schematic is you're looking at an engineer thinking about this like this. So if you got brushes on either side of it, it's going to run a certain speed. If you move a brush up here, it's going to change the speed of the motor. That make sense? Hello? All right, now then, you see this? That's what you're looking at is the end of that commutator. That's a brush, and if you're going to change the speed of it, see, you're actually going to energize a different brush. And all complicated. Fan strategy. Get the strategy down pat. Go to description and operation. Radiator fan control. Fan on, 104 degrees Celsius. High, 110 degrees Celsius. There's your Fahrenheit reading. Fan off, and it tells you when it comes on, when it goes off. AC on, fan on. If you meet this criteria and the fan's not on, you need to be figuring out what's going on. It'll also tell you how it all works down here. That's in your description and operation thing, what that is. All right. It provides fan control. The fan will not run during cranking until the engine starts, no matter what the cooling temperature is. You need to know that, don't you? All right, so the fan will run when the air conditioning clutch is engaged, low pressure cutout switch is closed, 1 second pressure head pressure reached. and the fan will run according to the following information charts, and that's what I had up here on the top right. All right, so there's your fuse panel right there, AC air compressor clutch relay, heated seat relay, fuel pump. Find those things. You got to look. There's your relays right there. You got them fan relays. There's your low-speed radiator fan relay, right? All right, so that's what that's going to look like. All right, so and here's what it looks like in the real world, sort of, and that's what it looks like over there. This relay and that relay, same thing. All right, so when the circuit's working right, the relay's closed, you got 20 amps throughout the circuit, right? Now watch this. I want you guys to burn this in. Don't forget this, because usually when I come along and I give a test, everybody goes, duh, I don't know, and their eyes glaze over. You're going to have right here, you're going to have 12 volts. When this is closed, you're going to have 12 volts here, you're going to have 0 volts there. But you're going to have the same amount of amps down here as you got up here. Amps are constant throughout the circuit. Since you're using ground for your reference point, you're going to not have any volts here, but you're going to have volts here. But just because you ain't got no volts here, don't mean you don't have amps here. You can measure your amps on the negative side just like you can the positive side. All right, we pull that relay out. All right, you got that. I took that relay out of the circuit. All right, and then we find no power feeding the fan relays. You got a fuse right there, power distribution center, fuse 12, 40 amp fuse, supposed to be feeding power down there. There's no power there. No power there, are we going to have a fan? No. What turns on the fan? The relay turns on the fan. And I'm looking for this. All right, we pull that relay, we pull that fuse out, and we had this. That was the problem. Got all chalky, melted everything. Fuse was not blown. Fan circuit sometimes fail that way. Slight resistance creates heat. Oxidation becomes major resistance. Current flow stops throughout the circuit because of this one failure point. And that just, everything comes to a stop. It's like a bridge that you can't, you know, a drawbridge that you can't get through. A switch is kind of like a drawbridge. This here is basically like something, somebody's built a wall. All right, sometimes the fuse panel will need replacing in these cases. Always inspect the connectors. This headlight connector failed for the same reason and in the same way. You get it? Sometimes the headlight don't work. If you jiggle that connector and it's blinking off and on, unplug it. If it's all burnt like that, you can get a pigtail from the parts store, solder it in there, get you a new bulb, plug it in, you're in Fat City. All right, there you go. Blower resistor, this connector failed for the same reason. Blower don't work, reach under there where the blower resistor is, jiggle that connector. If the blower comes and goes, probably got issues with that. In extreme circumstances, I have, usually when it's scorched and melted like that, you need to replace this and the connector. But what I have done is scratch that thing really, really, really good and scratch the other one and tweak it where it'll bite tighter, and then put some dielectric grease on there and plug it in. Dielectric grease keeps oxygen from getting up to it so it can't oxidize again. Sometimes that'll fix one. But you got to realize, you know, you can actually have a problem here. Human error could be the cause. This created an engine skip. Somebody plugged the coil in, you know, jacked the lead in there. When they plugged the coil in, they bent the tang. Not good, huh? All right, look for bent pins. Look for spread pins. If you're using a test light, a tapered test light, and you ram it into a connector so you spread it out, then whenever next time you plug it in, you're going to have this. It ain't going to be touching nothing. And boy, if somebody does that in a fuse panel, that will drive you up the wall trying to find it if you don't actually, if you're not able to see it. I've been there. Relays aren't always replaceable. Some of them are built into the doggone junction box. We've got CM junction boxes up there, them fuse panels. Some of the fuse panels we've had to replace because they had a bad relay in the panel and you couldn't replace it without replacing the panel. Usually a salvage yard will have a fuse panel. All right, so, but if it's got numbers, if it's got these numbers here, you'll know that you can replace it. If it doesn't have numbers, you'll know you can't. Now, what does the dotted line mean?
It's not the full picture there.
Not the full picture. You're not seeing the whole thing. See, it's the same way here. All right, remember that. All right, so notice the terminal numbers on the replaceable relay, 87, 86, 30. 30 is typically going to be the common terminal. All right, so that's a replaceable relay. This is a non-replaceable relay. No terminal numbers means you have to replace the entire module. Okay, you got that? Measuring current draw. Sometimes a motor or other component might pull too much current because of compromised winding. See how they're burned? Wires are coated so current can't pass from one loop to the next. When the coating fails, the motor fails. Burned motor windings on a fan motor can create radio frequency interference and cause the fuel injection system to do stupid stuff. Magnetism weaving across copper wires makes voltage the PCM doesn't know how to interpret. Bench test whenever you can before replacing parts. All right, that was a quickie. And you guys came in right on the tail end of it. How about that? You'll have to watch it on YouTube. All right. Anybody got any questions? Did you retain any of this stuff I went through so fast? I mean, I could have made this into an hour-long presentation and told a lot more stories. But I've tried to get through these things quick. And Timothy's over turned into a skeleton, you know, and all that. So,
Tim,
all right. Yeah.
don't
So-
be turning into a skeleton.
So what do
when I
You
see-
do it, Timothy.
Yeah. So what do you think? Let me guess, the battery was dead on the van. There's a parasitic drain on that thing we've got to find.
Man, when I say that thing was going crazy, like
But it's
and then
too
the
hard, like-
speed